In this video, I want to talk about the transpose of a matrix. Now, the idea of a transpose of a matrix is actually really simple. It's straightforward to calculate, and the only reason that I haven't introduced it previously is that we didn't need it yet. It's something that I could have talked about right away. You don't need any special techniques to look at the transpose of a matrix. So what is the transpose of this matrix that we have in front of us? Well, it's this. We write it A with a superscript T. Sometimes you'll see that as a capital T or as a lowercase t. It doesn't matter. It's pretty consistent that if you have a matrix with a superscript T of any sort, it's referring to the transpose. Now, I recommend pause the video if you like, stare at these two matrices, try to figure out how do you get between these two? How do you take a matrix A and get to its transpose? So how do we do that? There's three equivalent ways of thinking about this. The first is that we're reflecting across the diagonal. So we're reflecting across this line here. And so if you imagine flipping across this line, you'll take the matrix A and you'll get A transpose. Another way of thinking about it that I think is almost a little easier to write out is that we're switching rows and columns. So the first row of A was 1, 2, minus 1, 3. The first column of A transpose is 1, 2, minus 1, 3. Or we can think of it the other way, right? The second column of A is 2, 5, 1. The second row of A transpose is 2, 5, 1. So we're switching rows to columns. And then a third way of looking at this, if we want to just go entry by entry, is that the ijth entry of A transpose is the jith entry of A. So for example, let's actually write this out. If I wanted to know what A transpose 2, 3 was, that would be A 3, 2. A 3, 2 is this entry. And so that's 1, which we see here as A transpose 2, 3. So these are three ways of thinking about how you find the transpose, and they're all useful to have. That is, you don't want to just settle on one of them. You want to know all of these three things. In different situations, it's useful to think of the transpose in different ways. All of them allow you to really quickly write down the transpose of a matrix. All right, so why do we care about matrix transpose? Why are we talking about this? This is going to be the kind of thing that shows up in a lot of computations. And there are going to be lots of situations where we want to take the transpose of a matrix and multiply it by something, or something like that. And that's why it's useful to have a symbol, and it's also useful to have a term for it so that we don't have to constantly say things like, switch the rows of A to the columns of this new matrix, right? We just have a set term for it. Finally, we know how to find the transpose. Whether or not you believe that it's useful yet, you will see that, right? We'll use it. It'll show up in computations. But finally, are there any properties, right? We introduced some new notation. We want to know, how does this transpose behave? Well, the first thing to notice is that these processes, if you do them twice, they undo each other, right? If you reflect across the diagonal twice, if you switch rows and columns and then switch rows and columns again, or if you do this entry by entry thing twice in a row, you undo everything. And so another way of saying that is that the transpose of the transpose is the original matrix. That's one useful property. There's two other properties that are less obvious, but not that hard to see that they're true. I'm not going to go through why they're true. I just wanted to present them. If we multiply two matrices, so if we're allowed to multiply two matrices, if the dimensions line up, and then we take the transpose of that, that's the same as first taking the transposes of the matrices and multiplying them in the opposite order. We saw this with inverses of matrices. The same sort of thing happened. So in some sense, transpose distributes, but distributes and switches the order. And then finally, I just mentioned inverses. If we have an invertible matrix and we take its transpose, we get a new invertible matrix. That new invertible matrix is the inverse of the other matrix is transpose, right? So if A is invertible and we take its transpose and then look at the inverse of that matrix, or it is invertible for one, and its inverse is just the transpose of the inverse. We probably won't see this in this class, but this is something that shows up a lot for me personally in my own research. And so we'll get sloppy and write things like A negative T, right? Combining the -1 and the T, saying we're taking the inverse and the transpose. Doesn't matter what order you do it in, it's the same thing. Okay, so I'm going to stop there. I didn't want to make this a long video. That's what the transpose is. If you've never seen it before, it'll show up all the time in formulas. And again, it's not hard to calculate. You do any one of these three things. I tend to think that the quickest way to write it down is, using number 2. Just write down the rows or columns in the opposite way.